Okay, so today we're talking about tuples, and tuples are the kind of other major data structure in Python. We have we've covered lists, we've covered dictionaries, and we have tuples. Tuples are a lot like lists, um, and a lot of times we use tuples and lists almost interchangeably. But tuples are immutable, okay? And that's the key difference between lists. So you might think, as I go through tuples, you might be like, well, why are we bothering with tuples? Like, is there anything a tuple can do that a list can't do? And the answer is kind of no. Everything a tuple can do, a list can do, but more, except tuples have the very important property of being immutable. And sometimes we need that immutable property, especially when we are dealing with dictionaries and stuff. So as far as dictionaries go, remember the keys have to be immutable. And so you can use a tuple as a key, but you cannot use a list as a key, okay? And the reason why dictionaries have to have immutable keys is that we don't want values that we're going to look up to change, right? So it would be kind of like if you have a literal dictionary. I'm just wondering now that because you guys were all born, I don't know, probably like year 2000 or later. Maybe some of you are like 1999 or 1998, but most of you probably were all born quite late. Did you guys use physical book dictionaries, or what was the dictionary always a digital thing for you? Okay, so yes, all right, okay. So you had 24 physical book dictionaries? Okay, all right, so everyone's saying yes. All right, okay, I don't know, what about a physical book encyclopedia? Did you ever use those? I'm just curious about that. Yes, also? Yep, yes, in school. Your grandma has one, right? I mean, that's what I'm talking about. So, when I was in school, we had physical book encyclopedias, and that was like the only encyclopedia. And then, let's see, I think Wikipedia, I was in high school when Wikipedia kind of became a thing. So I don't think like my children will never use, not never, but I can't imagine them using a physical book encyclopedia. Like we've got the internet, right? So, but anyway, okay. Yeah, the book encyclopedias used to be like this status symbol. Like if you owned the encyclopedia, that was like you had money and you valued education or something, right? Okay, anyway, let's talk about tuples. So anyway, if you had a dictionary, so what I was talking about was if you had a dictionary and the words that you would look up changed, then the dictionary would be like useless, right? So we can't have the keys in the dictionary being changing. So tuples are immutable. And so they can be used as dictionaries, right? So anyway, we create tuples just by taking values and separating them with commas. So here we go. So here I've got T for tuple is 0, apple, 2, cat, dog, 5, 6. Okay, so you can just do this, and this will make a tuple. Parentheses are not required to create a tuple. We often use them though. Okay, so here is the tuple, and when you ask Python to print out the tuple, it looks like this. You can use parentheses, and this is probably the most common. Like when you see code written, you often see parentheses used for the creation of tuples, and they're exactly the same. They're exactly the same. All right. If you want to create a tuple with one value, you need a comma, so you can do this, and you'll get a tuple. Type tuple. If you just use parentheses without a comma, this is not going to work. That's going to just remain a string. Okay. You can make an empty tuple with a tuple function just like this. I don't know what you would really, because tuples are immutable, All right. So unlike a list in the dictionary, like with a list, you create an empty list and then you append values to it. With a tuple, if you create an empty tuple, it's going to remain empty tuple forever. This is it. Tuples are immutable. So you can't, like, unlike a list or dictionary, you can't just create an empty thing and choose to add things on. Okay. Lists and dictionaries, it makes sense to start off with an empty list and then you kind of add entries as you go. But that's that, right? So you can use the tuple function to turn other iterables into tuples, okay? So here you can have, you know, a string is an iterable, right? And so you can take the, you can throw the string hello into a tuple and you get this. I mean, you can do this with a list also. You can just say list on hello and it will do the same thing, except you'll have square brackets rather than curved brackets or parentheses at the end. So that works. You know, tuple on range will give you the, basically this. Again, this works with a list as well. Here's a, take a list and you can make it into a tuple. You can also take a tuple and make it into a list. So, okay, and then the usual indexing rules apply. So if you create a tuple like this, you can subset them and you can say, give me index 1, that's Apple. Give me index, or give me the slice 2 through 5. So you'd go from the 2nd comma up to the 5th comma. Okay, and you'd get 2 cat and dog. Tuples are immutable. So I keep saying this. So anything where you try to modify the tuple, it's going to break. Okay. So here, T is a tuple, L is a list. So these two things are exactly the same. The only difference is this one I put parentheses to make it a tuple. Here I put square brackets to make it a list again. And then these parentheses were optional, but just to kind of illustrate, I did that, right? Okay, so here, if I take the list and I say change the 0 index, take 100 and assign it to the 0 index and list, it works. It works, no problem. Okay, you do that with the tuple. You say take 100 and assign it to the 0 index in a tuple. It says tuple object does not support item assignment. Okay, so Python will give you an error. All right. With the list, you can append values like x, right? So there's several things that modify lists, right? Append, insert, pop, extend, all of those kinds of things will work for the list, but you try to do that with the tuple. It says tuple has no attribute append or no, you know, there's no method append for a tuple, so it's not going to work. Okay. So you can replace one tuple with another. So here, you know, going back, what was the tuple? The tuple started off with the number 0 here. Okay. And so if I wanted to do this, I can say, here, let's make a tuple with the letter A and then add on the rest of the first tuple. Okay. And this is, and it creates this. All right. But this tuple here, this is an entirely new tuple. Okay. It's unrelated to the other one. So we're defining an entirely new tuple, and yeah, unrelated to the other tuples and things like that. Okay. Whereas with lists, you know, if you looked up that ID property to see, you know, what object it is in memory, you know, you could be modifying these things. All right, you can do, so a lot of these things with tuples will also work with other sequences, all right? And so, so if you do some kind of relational operation with this, what it does is it compares the first with the first, the second with the second, and then as soon as it, as soon as this goes, it's gonna kind of, if they're equal, then it moves to the next one, okay? And then as soon as it gets some kind of result, it's going to return that. So 0 is equal to 0, so it's going to continue to the next one, and it's going to compare 1 versus 3. 1 is less than 3, so it returns true, okay? Here, even if I have this, okay, like 2, whatever this is, 2 million, is much bigger than 4, again, it's comparing 0 versus 0, then 1 versus 3, okay? And it doesn't compare this and this, okay? So it's kind of like if you had to sort entries in the dictionary, okay? If you have A and then B and D, okay? So you know the word ABZ, that's not a word, but ABZ will come before the dictionary than AD, you know, C or something, okay? So even though Z comes after C or whatever, it gets sorted, you know, based on the order here. All right, so this is kind of a neat little thing you can do. You can use tuples for assignment, right? So let's say you had 2 values here. You have A equal to 5 and B equal to 1. And if you wanted to switch those values, you know, kind of the old way you would do this, like R doesn't support this. So if you wanted to swap the values assigned in R, you'd have to create something like this. A would get assigned to a temporary value. Then you would take B and replace A with it. And in order to get, and then you take that temporary value and you assign it back to B, okay? Because if you just try to do A equals B and B equals A, or A assigned to B and B assigned to A, you know, one of those values gets lost, right? So you have to kind of store the 5 into a temporary location. Then you can replace A with 1, and then you take that 5 and you store it back to B. And then, so when I print this out, I get 1 and 5, okay? Here, you can just do this, okay? So I've got A is 5 and B is 1. I can just do A comma B gets assigned to B comma A. This is great. This is so awesome, okay? So, like, I don't know if you guys did this, for like the greatest common denominator function that's in your homework, right? You know, how do you find the greatest common denominator between 2 values? You know, if you just do like A divided by B, that's kind of assuming that B is always smaller than A. But if, you know, it's probably a good idea to check if one value is bigger than the other, or if the other value is bigger than the other. And if you need to swap them, this is how you can do it, okay? You know, probably you didn't do this in your thing because I didn't teach you tuples yet. So you probably had to use something like this in your function, totally fine. But, you know, sometimes a function, you expect the bigger value. The bigger value has to come before the smaller value or something like that. And you can do a check to just kind of make sure that's the case. And if you need to swap them, you can swap them like this. So. Okay. What do we have? You can take the results of a function and have the return values assigned to a different element, different elements in a tuple. I think we saw this already. So string.split, you have a string here. We're going to split it at the @ sign, and we can assign the results to username and domain, right? So if we do this, it's going to take the string in front to assign it there, and the string after gets assigned to domain. So we can do that. Here you can have a function. We've already talked about this, but you can take the function, and the function can return a tuple, okay? And so when you do this, it returns a tuple. So if I do 23, and then we do, I've defined this division function where it's going to do x divided by y, and return the remainder, okay? So then we'll get us 4 and 3, 23 divided by 5. Or you can take the tuple and unpack them into a comma b, and you get a is 4 and b is 3. So that's great. Okay, there's only 2 methods for the that the tuple have. You got tuple index and tuple count. So here's our tuple that we're going to define. We can say, what is the index of dog? And it gives back, it's the index 4, okay? We can say count how many times the number 5 appears, and it appears once in our tuple, okay? So all the other methods that work for lists, such as apply and extend, not apply, extend and append and things like that, those don't work for tuples because those modify them. But so like a list, there's list.sort, which sorts the list in place and modifies the list. But sometimes you want, let's say you have a tuple and you want to sort it, okay? Well, there is the sorted function. There's other functions that work. These functions work for both tuples and lists. So you can ask, what's the length of a tuple? What's the length of a list? What's the sum if you've got numbers in there? Or what, give me back a copy that has been sorted and things like that, okay? So, so none of these functions affect the list or tuple. It just returns back a result here, right? So here's some digits, and this is a tuple of numbers. Here's a list of words, okay? So we can say, what's the length? What's the sum? Obviously you can't sum the strings, okay? You can sort. You can ask sorted on digits, right? So sort the tuple, and that will return, the object returned is actually a list, okay? Whereas, and if you look at the original tuple itself, it remains a tuple and it has not been affected. Okay, sorting the list of words and stuff, and you can ask the minimum of a tuple and things like that. So all of these things still work. Okay, we can do math operations. We can, these are kind of the things like that we might expect. So here are lists, and you can do ×2, and that will kind of duplicate and extend the list. It's going to just kind of duplicate ABC. You can add the thing. This is an entirely new list, right? So this list that is returned here is not a modification of L1 or L2, but this is an entirely new list, okay? This is also an entirely new list. And so these things that return entirely new lists or tuples work over here. So we are not, this tuple T1 is immutable. It's always going to be ABC, okay? And so here I do T1 times 2, and I get this. Now, if I wanted to overwrite, and I can assign this back to T1, and I've created a new object, and I've, taken that new object and I can bind it to T1, that's fine. This is an entirely new tuple, and I can assign it wherever I want. Okay, I can kind of combine these tuples. And again, these are new tuples unrelated to the ones that we've created earlier, right? You can't add a list and a tuple together, okay? So you can't concatenate a tuple to a list. So you can either convert the tuple to a list, okay? Or you can convert the list to a tuple or something so that they're the like type, right? So here I chose to convert the tuple to a list, and I can add them together. I can also convert the list to a tuple and combine them. All right, so this is a neat thing that that Python does, and you can allow for variable length functions or variable length arguments in a function. So in R, you have something called the ... argument. You can pass multiple arguments using ... You can do something similar here in Python using the star. The star operator will gather arguments into a tuple. The kind of the parameter that you're gathering together can be named anything. Args is kind of the convention, so it's going to be called star args, and you'll encounter that. So here we can define a print function with star args, okay? And what it's going to do is it's going to accept a tuple of variable length, and here we can kind of iterate through all of these things. You know, maybe I should do a better example here. All right, so I've got this. I'll take another print lines on star args, and then so I can do for element in args, we can do print element, okay? And so we'll do that. And I'll do print lines, and you can give it a tuple. Hi, goodbye. Okay, and that will work. Print lines, and you give it just something like this, and it will kind of, it'll gather all the arguments, okay, and it will you know, it gathers them together into a tuple, and it will iterate through the tuple via, you know, some kind of operation like this, okay? So so that's kind of nice, right? You can actually I'll do it later. You can even have star for gathering dictionaries, okay? So you can kind of gather an unknown length of dictionaries, and you can do star keyword arguments, star quargs, and that will also work. But I guess that will be another a different slide in a different lecture. Okay. The opposite of gather is scatter. Okay. And so if you have a sequence of values and you want to pass it to a function as multiple arguments, you can kind of use the star operator, right? So for example, we have this my_divide function, and it takes two arguments, x and y, all right? And it won't work with a tuple. So if I take the tuple and I want to do 23 divided by 5, okay, I can't do my_divide t. If I do this, it tells me it's missing one positional argument, right? It takes the t and it assigns it to x, and it's looking for y, and it doesn't know what to do, okay? But on the other hand, if I take this tuple, I can put star in front of it, and it will scatter, okay? So so when you define the function, you can put the star in it, and it's going to gather, you know, whatever gets passed to it into a tuple. And then on the other hand, when you call a function, you can use star on a tuple, and it will scatter. It will scatter the elements in the tuple across the arguments. You know, assuming that that there's a appropriate matchup of values there. Okay, so it's kind of a nice nice feature that can certainly simplify certain operations, right? So you can have a function and it returns a list of tuples, and then you can kind of just pass that list of tuples into another function without having to kind of process them that much, extensively further. We saw zip. Okay, we saw zip on Wednesday when we talked about dictionaries, but here we'll take a look at it again. And basically it takes a couple of sequences and it zippers them together, right? It interleaves them. So here I've got a sequence, a string sequence ABC, and I've got a tuple 0, 1, 2, and I can zip them together. Now when you zip them together, you get back what's called a zip object, okay? It just kind of exists in memory. And if you want to do anything with it, you have to ask Python to do something, okay? The zip object is technically called an iterator, okay? And it allows you to iterate through them. So what this does is it creates basically a sequence of tuples. So here's the zip object. I can say for each pair in the zip object, go ahead and print out the pair. And we can see that each element in the zip object is just a tuple. It's a tuple where it zipped the A with the 0, the B with the 1, the C with the 2. It kind of just matches these things up, okay? And so, so it's a lot like a list of tuples, but it's technically a zip object. So you can't just call the zip object directly and say, like, give me the 4th zip object, okay? You've got to because the way it's working inside the computer is it's not actually thinking. It doesn't actually create all of this stuff all at once. It's like instructions, and it kind of goes as it goes, right? So as it's going through, it's kind of zipping them together. But if you wanted to, if you needed them all immediately to work with, you can take the zip object and you can throw it into a list, and you will get the list of tuples. Okay, this operation requires a little bit more computational power up front. Does T have to be a tuple? It doesn't. It doesn't. You can zip anything together. Like you can take a string and zip it with another string. You can take a list and zip it with another list. You can take you can zip strings and tuples, tuples and tuples, lists and tuples, and whatever you want to do, right? So any kind of yeah, if you have S and T with different lengths, you're going to get a zip object of the shorter length. So basically, the longer stuff that doesn't get matched up gets thrown away. So anyway, but yeah, so if you call, take the zip and you say make a list, this is gonna, if you've got a big object, it's gonna require a bit of computational power to kind of zip every single object together. Okay, whereas when it's just a zip thing, okay, this is kind of just like instructions that says, hey, when you're ready, you better start zipping these things together, right? And it's zipping them together when I call this. When I say for each pair in here, then it says, all right, let's zip these things together. Now, for a thing with 3 lists, 3 elements, who cares, right? But if you got like a bajillion, this operation can take a while. Whereas creating the zip will actually be quick. Oh yeah, sequences are not the same length. The result is the length of the shorter one. So here I've got a sequence ANNE and ELK. This last E gets thrown away. Okay, and there you go. And then so if you have a list of tuples, or basically a zip object, and you're iterating over them, okay, you can unpack the elements. So here I have a list of tuples, and you can unpack them as you iterate through them. And so you can say for each letter and number in T, so it's going to unpack this. We can say print out the number followed by the letter, right? So we're going to print out 0, then A, and 1, and B, and whatever you want to do, okay? But you can iterate over them and unpack them in this way. So here, this is straight from the textbook, but let's take a look at what this is going to do, right? So it says has match, and we just arbitrarily called it T1 and T2, but this is basically any sequence 1 and sequence 2. We're going to zip these together, right? So zip will accept lists and tuples and strings and whatever you want it to do. It's going to zip those two together. And we can unpack the zip object directly. Okay, we don't have to up front throw it into a list and have the computer compute out every single zip thing. Okay, it's going to kind of go on the fly. It's kind of like, I guess you can think of it as you have like 2 stacks of papers or something, right? And one is, you can say, okay, we're going to zip these together, right? We're going to kind of collate each element in these stacks, and we're going to, create one giant stack. And you can say, I want you to do this now, because when you call list on this, list on the zip, it's saying, take the 2 stacks, and I want you to merge them now, and then work through it, okay? Whereas when you just create the zip, it's kind of like you put the 2 stacks, you leave them in a form of 2 stacks, and then as you operate, the computer is just grabbing each element and zipping them together at that moment, right? So anyway, what we're doing is we're just going to say, all right, let's zip these together. We got X and Y. We're going to check if X and Y are equal to each other, and if so, return true. We stop the function, we're going to return true. So if the third element in X matches the third element in Y, great, we found a match, and then we're done, right? But if it finishes the entire for loop without finding any kind of match, then the function will end, the for loop ends, and then we're going to return false. So if we finish the for loop without ever encountering this state, we're going to return false. Okay. So if I go A, B, C, D, E, F, we say, does A match with D? Nope. B match with E? Nope. C match with F? Nope. So we finish the loop and we return false. Here I have, does A, B, C match D, E, C? A match with D? Nope. Go to the next. B match E? Nope. Go to the next. C matches C? Yes. Okay. And so returns true. So, so this is just a simple function. I'm sure you can think of more interesting ones but that make use of this kind of stuff, right? And so the zip is nice because it's inherently lazy, right? It only starts collating these when you ask for it. Okay. Similarly, enumerate does this. Okay. Enumerate is kind of like zip, except it only takes one thing, and the thing that it's zipping against is basically a range object of the same length as the same length of the iterable that you pass to it. Okay. So enumerate is kind of like zip, except you're only giving it one thing and it's zipping it against integers, right? And so when I do enumerate ABC, basically it's going to return 0 gets matched with A, 1 gets matched with B, 2 gets matched with C. Maybe this was, maybe I should have used something other than ABC. Because it's not anything related to the positioning of the alphabet, right? So I can just good morning or something like that, right? So if I do that, oh, I'm going to do this here. Okay, and it's going to go each element. The first element in good morning gets matched with 0, then the next gets matched with 1 and stuff. So this will kind of basically return the index of each of these things. So if you've got some kind of list, it works out here. Okay, and similarly, you can throw it into a list if you need to. That's too much. Okay, I'll just do morning for all of these things. Okay. Okay. We talked about the dictionary view object, items. That's going to be a sequence of tuples. So here I define a dictionary. Dictionary ABC 012. I could have just enumerated ABC and I would have gotten the same thing. But here we go, right? So yeah, I could have just done D is equal to dictionary on enumerate ABC. So there's lots of handy little helper functions, right? That go, and again, just like, but you got any other dictionary, dictionary items can get unpacked into keys and values, and you can print them out just as we would expect. Or actually, oh, you know, this is not true. If I enumerate ABC, 0 would be the key and A would be the value. So I would have to swap them all. Here, let me just show you. Okay. Let's make a new slide here. All right, so I can do D is equal to dictionary on enumerate. Let's just do EFG. Okay. So, oops. So we'll call that, and we'll. Okay, so I get this. Can you guys think of a way very quickly to take all of the elements in the dictionary and swap them? So what if I want to swap the keys and elements in a dictionary. Can you guys think of something? All right, so I can do, yeah, you can do a for loop, right? So a quick for loop. So I'll make a swapped dictionary, right? So we'll create empty, and we can do for we'll do key and value in the dictionary D. Okay. All we have to do is we'll do swapped, and then we'll do the value equals to the key. Okay. No, what did I do? D here for key and value. Int object. Oh, D dot, thank you. Okay, there we go. Thanks. All right, there we go. D dot items, exactly. So that works. Okay, so just very quickly, you can kind of swap all of these things. I mean, you got to iterate all of this, but you can do, right? Okay, we can create, and of course, if you didn't want it, you could just in the first place, if you knew you were going to try to create something like this, where each letter, you could have also just done zip dictionary on zip on EFG range, 3, right? So if you knew exactly what you wanted, right? But here, this is just to kind of swap everything. All right. Making dictionaries out of tuples and zips. Okay, so we saw this on Wednesday, so no big deal, but you get a list of tuples, you can make a dictionary out of it. You got a zip object, you can make a dictionary out of it. Okay. You can use tuples as dictionary keys, right? So tuples are immutable, which means they can be used as dictionary keys. So here's a situation where this could be useful, right? This is a silly example, but you might have some kind of function that's very expensive to compute. So like you've got some value x and some value y, and maybe this part, whatever number you put in, it takes a long time. So let's say you have the Ackermann function, right? That Ackermann function, as soon as x gets to be a huge number, it takes a long time to compute because there's so many things, and possibly it breaks your computer and it says like you've reached the max iteration count and stuff. So like you don't want to bother having to compute. So what you can do is you can create basically a lookup table, okay, but it's really a dictionary, a lookup dictionary, where you're using tuples. You've got basically a two-dimensional tuple to look up the corresponding value, right? And so what you can do is you can create a dictionary that's going to store the known results, right? So I'm going to just start this off and say, for the pair 0, 0, we know that the result is 0, okay? And then we can define our function. And here I intentionally added some extra stuff that's unnecessary. But we're going to define our function x of x and y. We're going to gather the values x and y, okay, into a tuple here. And we're going to say, let's look up if t is in the dictionary, right? So we're going to look up the key. Is this key, x, y, in the dictionary? If it is, we'll say value already exists in the dictionary. And then we'll just return the value associated with t in the dictionary, okay? On the other hand, if this doesn't exist here, we'll say the value has to be calculated. And then we'll go through the calculation, which, you know, for this thing, it doesn't matter. It's super easy. But you can imagine some kind of function like the Ackermann function where it gets very expensive to compute. Okay. And in that case, we will take the result and we will store it. We will store it into our dictionary. We'll store it into our dictionary, and then we'll return that result. Okay, so let me just show you how this runs, right? So if I look up 0, 0, it's going to say, all right, that value already exists, and the value is 0, right? Here, I put in a new thing, right? 1, 2. Value must be calculated, and it calculates it, and it says, all right, that number is 5. And then later on, if I call 1, 2 again, now that value is entered into the dictionary, and it says the value already exists in the dictionary, and it can just look up the value 5, which is quite nice, right? And so the known entries are listed off in the dictionary. And so using a dictionary as some kind of lookup tool for known pairs of keys is a handy thing. And the fact that you can use tuples as keys allows you to create some kind of dictionary where you can look up values where you associated with 2 values and things like that. So that's kind of a neat application here, right? And I think this is the last slide. All right, so I just wrote, in many contexts, the different kinds of sequences can be used interchangeably. This is not always the case. Obviously, you can't use lists as keys in a dictionary. Okay, and let me see, was there anything else from our chapter on tuples? That's on dictionaries. Okay, so on tuples, last thing, it talks, okay, all right, this is useful. So in some contexts, like a return statement, it's syntactically simpler to create a tuple than a list. If you want to use a sequence as a dictionary key, you've got to use an immutable type like a tuple. And if you're passing a sequence as an argument to a function, using tuples reduces the potential for unexpected behavior due to aliasing. Yeah, so that's about it. That's about all I've got for tuples. I'll make your next homework assignment that kind of covers these later data structures, and we'll end there. Have a good weekend, you guys. Oh, quiz answers. Oh man, I've been slacking on this quiz answer stuff. I totally forgot. Let me look up. What were the quiz answers? I created the quiz. So good job me this time. And I created the quiz. Let me look up the answers for you guys, because I totally forgot and I didn't write them down on a piece of paper. So I don't know. Log me in, please. Let me see. Okay. Let's go into. Oh, who attempted my quiz? Man, I don't know. Okay. Answers are D and C. Answers are D and C today for today's quiz. Okay. So so that's what we have. Thank you for reminding me on the quiz answers there. Okay. So we'll end there, and we'll see you guys on Monday. Have a good weekend. And
can I ask you a quick question about
the
homework?
Yeah. Let me hold on. Let me stop the recording for a second.